Dangasi, taking up of Bachelor of Science in Maritime Transportation. Before we start my topic, I have something to share you first. The history of general cargo vessels. The contemplation general cargo vessels was used for all types of vessels in around the late 1500, when the international trade began to hit the global shipping market. All vessels at the time were made with the same elemental concept without considering the fact that different cargoes need different degree of care and attention, as there was a little way of specialization. However, over time the vessels started becoming more involved. The need for specialization was soon seen worthwhile. Another reason was also that the increase in international trade demanded a high quantity of the single commodity to be transported from one place to another. This was a primary reason for all introduction of different ship types. Primarily, the transportation of bulk liquids began in the year of late 19th century, when the discovered and expedition of oils began. Tankers, however, are not just restricted to one particular type of variety. There are many varied types of tankers that are used in the process of oceanic cargo transportation. This classification of tanker can be based on several factors. Now let's move to my tab, the types of tankers. First is oil tanker. Oil tanker, however, is a generic terminology and includes not only crude oil but also a petrol, gasoline, kerosene, and paraffin. An oil tanker is designed to carry petroleum products in bulk. These vessels carry a wide range of products ranging from crude oil to refined products. Their size is measured at tons or deadweight tons. Its size range from 55,000 deadweight tons to VLCC of over 300,000 deadweight tons. Most of these oil tankers are owned and operated by commercial oil importers or exporters and even the governments. Due to their immense size, they have become quite cheaper and transport petroleum products from one place to another. Literally, for a typical oil tanker, this costs around 2 to 4 cents per gallon only. Oil tankers are further subdivided into two main types: product tankers and crude tankers. Product tankers are used to transport above mentioned petroleum-based chemicals. Product tankers are used to carry refined oil, various grades, to the point of near and the engrossing market. They are the smaller in size as compared to the crude oil tanker, designed to carry clean petroleum products, CPP, gasoline, diesel, jet fuel, and naphtha. Income from various size from 10,000 to 60,000 deadweight tons. Crude tankers are especially used to transport crude from the excavation site of the crude oil refining industrial plant. This tanker moves a large quantity of unrefined crude oil from its initiation point to the oil refinery, where they are refined and various grades or products are extracted and distributed later on. These vessels are much larger in size than the other variants designed to carry petroleum products in a bag. Their size is measured in tons or deadweight tons, ranging from 55,000 to ULCC ultra-large crude carrier of over 300,000 deadweight tons. The biggest super tanker ever built was the Seawise Giant in 1979, which was a length of 458.45 meters and a deadweight of 763 tons. Now let's move to chemical tankers. Are those cargo tanker which transport chemical in a various forms. Chemical tankers are specially designed in order to maintain the consistency of the chemicals they carry abroad them. These tanker ships are applied with a coating and certain substance that help that need to be transported. Chemical tankers are tankers that are used to transport various liquid chemicals. Chemical tankers are required to comply with the various safety aspects detailed in the Part B of SOLAS Chapter 7. IBC code for each chemical tankers transport in the same kind of chemicals. They range from 5,000 deadweight tons to 59,000 deadweight tons. The size of each very smaller of this vessel is compared to the oil tanker due to the specialized nature of the cargo and the size restriction of port and shore facilities. It consists of various tanks which coating such as phenolic epoxy or stainless steel or zinc paint. Type of coating of their tanks determines the suitable cargo. The chemical which can be carried. Customarily, chemical tankers can be classified into three categories as their type. Type 1. Product which possess very serious environmental and safety hazard which required maximum preventive measure to prevent an leakage or of cargo comes under the Type 1 chemical tanker. Type 2. Chemical products which markedly severe environmental and safe hazard which required significant preventive measures to forestall any escape of such as cargo can be classified in a Type 2 chemical tanker. Type 3. Chemical tanker which transport product with apply severe environmental and safe hazard which required a moderate degree of containment in a damaged condition can be referred to as Type 3 chemical tankers. So, slurry tankers. Slurry refers to all those materials that do not disperse or dissolve in a water otherwise regarded as waste material. The slurry is used as a fertilizer and the slurry tankers help to haul slurry to areas where they can be put to productive use. This type of vessel is used to carry filtered products where it will be specifically orange juice tankers which are used to the cargo carrying of orange juice and mass quantities. They near carry concentrated of fresh orange juice originating from Brazil to the other parts of the world. One of the biggest juice tankers is a Brazilian tanker, Carlos Fischer. However, other fruit juice carriers are also available. These tankers have refrigeration, temperature controller, and preservation plants which help them to keep the juice fresh at all the times. Wine tankers. Transporting wine has become quite simpler and feasible in contemporary times as sleek tankers have come up which are used specifically to carry wine to their intended destination. These tankers are used in carrying wine from the place of production to their different destination. Wine tankers are for transporting already produced wine from one country to another country for packaging. Hydrogen tankers are cargo tankers used for shipping and transportation of liquefied hydrogen gas. These tankers are specifically designed to carry liquefied hydrogen gas in bulk. They can't be used to carry any other purpose. Kawasaki Heavy Industry was the first to design a hydrogen tanker. ITB, Integrated Tug Barges. In this type of vessel, the stern is jugged into a special type of tags which can easily be connected to the barge, establishing it has a single unit. ITB are prominently used in the eastern coast of the United States. These tankers are mainly tags attached to the barge, leading on the formation of a single cargo carrying unit. The carrying capacity of ITBs are not higher as a product of crude carrier, but that capacity is enough to meeting the market demand. A number of barges can be connected to a single tag to increase the carrying capacity. Gas tanker, they are the special designed to carry different form of gases. Technically, these types of vessels are more on cutting edge than any other type of vessels such as bulkers, containers, and other variety of tankers. The maximum size of vessel is to use average freight rate assessment method for calculating shipping rates. These tankers are around 240 meters, 790 feet long, and have capacities of 8,000 or 80,000 and 120,000 deadweight tons. They carry roughly 500,000 to 800,000 barrels. LNG are carried with temperature controlled tanks which are intended to transport liquefied natural gas. The carrying capacity is measured in a cubic meter. The first service of type is carrying was on January 25, 1959. These ships have a cargo carrying capacity between 125,000 meter cubic to 135,000 meter cubic. LPG, a gas carrying built for a transportation of petroleum gases in bulk. It carries some other gases like ammonia, propylene, and vinyl chloride. Tanks are insulted and pressurized with ambient temperature. Next is classification of tankers based on size. VLCC, very large crude carriers, has deadweight tonnage or cargo carrying capacity ranging from 250,000 to 320,000 tons. ULCC, ultra large crude carriers, are the largest shipping vessels in the world with size ranging become 320,000 to 500,000 deadweight tons. Due to their mammoth size, they need custom-built terminals. As a result, they serve as a limited number of ports with adequate facilities to accommodate them. Aframax is an oil tanker with a deadweight between 80,000 and 120,000 metric tons. The term is based on average freight rate assessment (AFRA) to standardized shipping contract terms. Zosmax is a naval architecture term for the largest ship measurements capable of transiting the Suez Canal in laden condition. Panamax or Neo-Panamax are the mid-sized cargo ships that are capable of passing through the lock chambers of a Panama Canal, which are 320 meters in length, 33.53 meters in width, and 12.56 meters in depth. Typically, it has a deadweight tons of 65,000 to 80,000 tons. The 9 classes of the IMDG code with the subclass and one example. First is subclass 1.1, explosive with a mass explosion. Hazard consists of explosives that have a mass of explosion hazard. A mass explosion is a one of affects almost an entire loads instantaneously. The example is dynamite. Next is subclass 1.2, explosive with a severe projection hazard consists of explosives that have a projection hazard but not a mass explosion hazard. Example is blast or fire. Next is subclass 1.3. Explosive with a fire consists of explosives that have a fire hazard and either a minor blast hazard or minor projection hazard or both but not a mass explosive hazard. Example is line throwing rocket. Next is subclass 1.4. Minor fire or projection hazard consists of explosives that presents a minor explosion hazard, and explosive effects are largely confined to the package and no projection of fragments and applicable size or range into a expected. Example is fireworks. Next is subclass 1.5. An insensitive substance with a mass explosion hazard consists of very initiative explosives with a mass explosions hazard which has a very little probability of initiation or of transition from burning to detonation under normal conditions of transport. Example is airbag inflators. Next is subclass 1.6. Extremely insensitive articles consist of extremely insensitive articles which do not have a mass explosion hazard. Example is explosives. Next is subclass 2.1. Flammable gas or flammable gases which ignite on contact with an ignition source. Example is hydrogen. Next is subclass 1.2. Non-flammable gases. Gases which are either flammable nor poisonous include the cryogenic gases, liquids, temperature of below 100 degrees Celsius, used for psychopreservation and rockets fuels. Example is helium or nitrogen. Next is subclass 2.3. Poisonous gases. Gases liable to cause death or serious injury to human health inhaled. Example is chlorine. Next is class 3. Flammable liquids. A flammable liquid means a liquid may catch fire easily or many mixture having one or more components with any plus point. Example is gasoline. Next is subclass 4.1. Flammable solids. Flammable solids means readily combustible solids and solids which may cause a fire through friction. Example is sulfur. Subclass 4.2. Substance liable to spontaneous combustion. Example is copra. Next is subclass 4.3. Substance which is contact with water emit flammable gases. Substances in these classes are either liquids or solid which by interaction with water are liable to become spontaneously flammable or to give off flammable or toxic gases. Example is aluminum carbide. Next is subclass 5.1. Oxidizing substances, while in and themselves not necessarily combustible, may generally by yielding oxygen cause of contribute to the combustion of other material. Example is calcium hypochlorite. Next is subclass 5.2. Organic peroxides. Organic peroxides are thermally unstable substance which may undergo exothermic self-accelerating decomposition. Example is melty ketone. Next is Subclass 6.1 Infectious substance. They are substances known or reasonable effective to contain pathogens such as a bacteria, viruses, parasite, fungi, which can cause disease in human or animals. Example is COVID-19. Next is class 7. Radioactive material means any material containing radionuclides where both an activity concentration and the total activity in the consignment exceed the values specified in a IMDG code. Example is enriched uranium. Next is class 8. Corrosive substance means substance which by chemical action will cause severe damage when in contact with living tissue, or in the case of leakage will materially damage or even destroy other goods or means and transport. Example is sulfuric acid. Last one is class 9. Miscellaneous substances and articles which during transport present a danger not covered by other classes. Example is nail polish or chemicals. That's all. Thank you.